Welcome back. Today we will start with the fourth module of this course, which is information centric networking. So what we will do in today's lecture is to basically understand the motivation for the information centric networking, why it is required. So we will spend some time in understanding how the content distribution actually happens in today's IP network and what are the issues, and then finally why information centric networking is required, and then how it works probably in the subsequent lectures. So in order to run that, let's begin looking at the history of the internet, how it evolved over a period of time. So the early usages of the computer networks or the internet were very limited. So as I said, only two applications were primarily were there back then in the early days of the computer networks, which is the email and file transfer. People wanted to send email from one person to another person, and then the files which are put in one computer were supposed to be accessed by someone else using the other computer. These are the two primary applications, and keeping that those applications in mind, the usage in mind, the designers came up with certain design which worked well and it served well for quite a good amount of the time. And the days passed by, so we came up with new applications. We started talking about remote access, remote login. Several other devices like printers were connected to the network, and then we had a remote access, printing the stuff from a remote computer, and stuff like that came into picture. The SAID file system and like that. But today, as we speak, much of the internet or the network is actually transmitting the multimedia content. So meaning we do have applications like YouTube and several OTT platforms which actually rich in multimedia content with the audio and video content, which actually constitute a major chunk of the total data that gets transmitted in today's internet. So this multimedia content back then, it was not actually the use case. The internet was not designed for delivering the such multimedia content. So what exactly is the issue with the multimedia content? Why it is actually an issue? So we'll try to run that. So in a nutshell, what we see as a network today, there are several data sources available on the internet or the network. There are several services that are provided through the web and the network, and there are applications which actually generate a lot of the data. So as from a user's perspective, end user's perspective, whether it is the data, service or the application, all of them are consumed as the content. So there is nothing like this is specifically for data, this is specific for the service, everything is integrated. So that's what the network of today's network look like. So how exactly this poses a challenge for designers and distribution, and that is the question. So internet was as keeping those two applications in mind. It primarily internet or the network, computer network, is designed for point-to-point communication. So meaning, if X and Y want to engage in conversation, they want to transfer some data. So be it the voice data, be it the packet data, be it the file data, doesn't matter what is the data. So you know who are the two endpoints which are actually engaged in the communication. So if X gives the data, the network knows how to deliver it to Y. Whether the same data is repeatedly transmitted, if let's say the same file is downloaded 100 times by my peer, then 100 times the network blindly transmit that data from location X to Y. So this is actually a kind of network doesn't understand what's exactly going on in the network. So that is the point-to-point communication. So if you, let's say the website is there, maybe a news website or like timesupindia.com or something like that, and whether I access, you access, as many users are there, those many unique users are there, those many times the same content is actually getting transmitted over the network to multiple people. But when you come to the multi-point distribution kind of environment, the scenario changes. When I say multi-point distribution, what I mean by that is the same content, if multiple consumers are consuming the content, if let us say I am downloading the timesofindia.com website and my neighbor is also downloading, reading the same newspaper, and the server is somewhere, let us say in Mumbai, and the same content is getting downloaded 2 times to my computer and also to his computer. So, there is a lot of redundant work that is going on. Is there a way we can actually minimize this transmission? So, that is the question, and the process of downloading the content multiple times is called as the multi-point distribution. So, the content distribution is an issue. In the multi-point distribution, there are many challenges. So, in the current IP network, one of them is the scalability. So, as I said, because the internet or the network works using the point-to-point communication, so even if I want to do multi-point distribution as well, I still use the same semantics of point-to-point communication. So, if n number of users are there or consumers are there, n number of the times the same content is getting repeatedly transmitted over the network. That becomes very inefficient. So, if you as the number of the users increase, then it poses scalability challenges. If let us say today 1000 users are interested in the same content, and tomorrow if 1,000,000 people are interested in the same content, then transmitting 1,000,000 times the same content over the network is not only challenging, but also it's actually is wastage of lot of network bandwidth. So, that way it is actually inefficient. And the second point is the users are mobile. I might be downloading the content on my mobile phone while I walk, or when I am driving, somebody sitting in my car might be downloading some content. So, when you are either walking or when you are actually connected to one of the mobile base station, so and that has got the antenna and the users are somewhere here, and as I move from one location, I might be connected to this base station or the mobile tower, and as I drive, so I am in the vicinity of some other mobile station, and as I approach the station, there is something that happens called as the handover. So the user is actually connected to the next available mobile tower which is near, which can give you better signal strength. So, when this mobility happens, when the user moves from one coverage area of one base station to the another base station, the existing connectivity to the server, let us say I am watching a video, I am connected to the YouTube server, and as I drive, so I move from one base station to another one. So, now the previous connection, so when I say the connection, this is typically the TCP IP connection that I am referring to. So, the TCP connection breaks down, and then you need to re-establish a new TCP connection to the same server and then continue to download the content. So, in a way, what is exactly the ongoing transmission from through one channel, one set of the routers, intermediate routers is actually broken and a new one is actually established. This is actually a challenge. And the third point is the current security mechanism. So, most of the time when we browse the internet or even watch the YouTube, you might see this HTTPS notation or the bar on the screen. So, that stands for the security. The security is actually given to if let us say this is the computer X and another computer Y, and the TLS, the way security works in today's network is through TLS or the SSL connection. So, it establishes a kind of the tunnel between two entities or two computers which want to engage in the conversation. So it says that I am going to give you this notion of this tunnel, whatever data you put it on this channel would be delivered to the other end securely. That is what the tunnel means. So that does not mean that data is actually not read by or not analyzed by the intermediate routers. That is a different story. The content itself is actually secure. I am going to give you this notion. So you put the content on one end and it will exactly come out at the other end. That is what the TCP axial security tells you, or HTTPS or TLS for that matter. So in that sense, so the security, the notion of the security that is existing today is not for the content itself. So we use a mechanism which is actually giving you an illusion of the security, a secure connection to the other party, and then on top of that we are actually putting the plain content. So that is what the current security mechanism look like. So now the question, an alternative and obvious question that comes to mind is there any alternative way of looking at the security? So for example, so when I transmit one chunk of the data, can I put the security for that chunk itself? So that is a notion which is actually not there in the today's network. So this point to point communication and today usage of the multi-point distribution and the security, the way security is provided to the content itself is actually kind of very inefficient way of operating the or distributing the content. So the more popular the content becomes, many people accessing the same content, because I am transmitting many times for individual user over the network, it becomes very less efficient. So if only one user is using, then probably it is as it may not be that inefficient, but the more the popular the content becomes, the larger the number of users access, it becomes less efficient for the distribution. So, but today consumption, the multimedia applications are operating in this format, the multi-point distribution. So, that is the challenge. So, with that background in mind, let us try to understand what are the mechanisms that we have built. So, because these applications are operating in this fashion and the IP network has been designed, TCP IP network has been designed with certain things in mind. So, some of the things we have invented or we came up with in order to minimize this overhead of transmission, to make it little bit efficient. There are a number of techniques that are retrofitted into the TCP IP model to specifically to deal with the content distribution problem, bring some sort of the efficiency for the content distribution. So, let us go over the one by one and try to understand what are those mechanisms, and then we will using that as a background, let us motivate ourselves for what the information centric networking actually brings onto the table. So, here is a picture which is actually showing on the left hand side we have server and a bunch of computers on the right hand side, and all these computers have got an IP address assigned to them. And let us assume this is the server which is hosting some content, maybe an YouTube server or any other popular web server, any which is actually having some content. On the other side, you have a bunch of consumers and they are accessing the content. So, every time this guy access, the content actually flows through a bunch of intermediate routers and it actually comes and get delivered to this point, and every time the second guy access, again it's flows through, the packet actually passes through, sent up again intermediate routers and then get delivered. Like this the content distribution is actually happening. So, this is when one guy access, when this guy access the content, and when this server is actually responding to that, this is a point to point communication. Only these two endpoints are now engaged in the conversation, and the intermediate router job is to just facilitate the transmission of the packet corresponding to that content over the network, over the multiple hops, it actually gets delivered to the right user. So we can say that as the number of the users actually increase, then the number of the times the same content is transmitted will also increase as the number of the users increase. So that is the inefficiency. So now what would be the better approach to do this distribution? So assuming the same content, same movie or same video file is being accessed by or requested by the all the users in the previous slide. Now what is the better approach that we want to bring onto the table? So let's say the content itself is let's name it as movie number 1, that's the M1. And if let's say the M1 gets transmitted to this router, the first top router one time, the content is now available at the router M1, router R1, the content itself is M1. And maybe this same content goes to this router, now the content is available at this router. And let's say all of these guys on the right hand side, 4 of them request the same content M1. So all that I can do is go to this router and ask, can you give me M1, and he gives. So this router can also ask this guy, can you give me M1, and he gives. So finally M1 comes from this router to this end user, and again the same M1 comes from this router to this guy, and this guy can access from one time, and then one time to this guy, and one time to this guy, and this is where the content can be, this how it can be delivered. So the end server actually give the movie M1 only one time, and these routers actually intelligently coordinated among themselves, and the content movie they made them available for all the end users. So effectively every link in this one, only one time the movie got transmitted from one router to another hop, or one hop to the another hop in simple terms. So this is actually a very good way of transmission. So earlier if 4 users were requesting 4 times the server was giving, but now some of the server gave only one time, and some of the routers requested only one time, and they were able to in turn serve to the many other routers in the network, and they might also serve many of the end users in the network. So this is actually very efficient way of doing the distribution. Now the question is, how do I achieve this? Is it in the IP network, is it possible to do it? So in true sense it is not possible to do it, but we have found out several intermediate ways of doing it. So we are not doing the exact same thing as shown in this figure, but something which is along these lines, a compromise between how many times I may not necessarily do only one time transmission, but something which is in the ground. Now let us take a look what are the mechanisms that are available to go here, but we are not at there. So many of us have heard this term called as the caching. So web caching is one mechanism. So I was referring to the timesofindia.com example. So let us say this is the server of the Times of India news website, and there are some consumers on the left hand side. What I do is, maybe let us take the example, an organization. So maybe IIT Indore is there, and there are a bunch of users inside the IIT Indore network who are interested in visiting the timesofindia.com website. And this caching server can, once the user number 1 using the PC number 1 in this figure actually makes a request, the content is actually delivered to that user. In the process, this caching server also keeps a copy of, or a local copy of, the same web page. And then when the user U2 from the another PC makes a request, the content, instead of going all the way to the Times of India server, the cached content can be served or given to the end user. So many times you might also notice when we actually visit website which are popular like google.com, the page gets downloaded quite quickly. So this is primarily because the page itself is cached. When I say the page, it is actually the search page, the blank space with the search bar, that page. The content itself is actually not cached in the server. if you are using the Google the page. On the other hand, in this case the timesupindia.com, the content might also be stored, because the same content is actually when user U1 is accessible, particularly when the user U1 and U2 are parallelly accessing, or they are along the timeline, they are actually close by. So, within fraction of when user 1 access, the content is delivered, and within a fraction of some time the user U2 also makes the same request, the content can be delivered, because by that time in few seconds or few minutes of time the contents on the timesupindia.com web server may not have changed. So, it serves as a good, it makes sense to cache the server and then space. But that is one way of doing it, and it obviously comes with some negatives. What is the negative? If the content on the main server change, then if you are keeping a local cached content, then the updated content may not be served. It goes with that assumption. So, here in this case, even if you cache the content, if I serve the cached content to the end users, the utility of that news, so all the page, entire page of the timesupindia.com website may not have changed, only a fraction of that might have changed, or one link or one image might have changed, but it still is useful user to. This is one way of doing it. So, obviously there is a limitation on how much you can cache, and because the as you cache size increases, then the as the amount of the data that you want to cache increases, then the storage requirement will also increase. So, that goes with that negative impact. So, that one way. The second is we have also built some protocols. We have also made the routers available, aware of such a distribution is happening. So, for example, on the left hand side, there is one source which is actually generating the content, maybe a video streaming content, maybe a video conferencing application is running, and the presentation is made from the source S, and these are the users, number 1, 2 and 3 are the users who are interested in that communication. If you use the plain point to point communication, every transmission originating from S need to be transmitted 3 times, one for this user using this link, and the second time for this user, third time for this user. So, from this point onward till wherever the routers are common on the path, there are 3 times. In this case, the 3 parallel transmissions are going to the same router from, let us say, this router number as 1 and this router as R2. Between R1 and R2, 3 parallel transmissions of the same content destined for 3 different users is passing through. Now, this is actually again it does not make sense. So, 3 times the same packets carrying the same content getting transmitted from R1 to R2. So, in order to deal with this, in order to reduce this transmission burden, so we designed something called as the multicasting route protocols, where we actually take the end users and then tell the nearest router, I am going to join so and so multicast group, so add me to that group. And let us say this guy comes and he joins. So, there is one transmission already going on from this user to from S to let us say R1, and now this guy comes, you go upon nearest point and then you join the same transmission, and when this guy asks, I also want to join, then you find out who is the nearest guy who can give you that content. So, this router turns out to the nearest point where you can get that content, you join that group. So, the routers themselves are organized in some kind of the tree kind of the architecture, where they make themselves aware that so and so content is being transmitted through me, and so it belongs to so and so group, and now whoever wants to join that group, I am going to give that content to that particular upstream router or the end user. That is what it says. So, we have built a protocol like group management protocols, where the routers are aware and the dynamic end users can dynamically request for certain content to be part of certain group or not group, and then the routers will manage the when the user is active, when the user is not active, when he is asking for transmission, when he is not asking for the transmission. This is called as the multicasting. There are bunch of routers, only a subset of them are actually interested in certain receiving the content. Only to those subset of the routers you transmit the content that is being originated at the S. So, this is called another way of reducing the burden on the system. So, at any point later point of time, currently this is how the picture look like. If these two guys walk out from the group, then this transmission will be broken. So, only from S to the user number 1 or the R1, the content is actually being transmitted. So, there are bunch of IP addresses that are reserved, which are actually used for this particular purpose. So, this is called IP multicasting. Class D address or group D address is actually reserved for this particular purpose. And the class D address, this is specifically whoever is part of that multicasting group, they need to use this particular series of the IP address. It starts with 111 followed by 0. That's indication that the multicasting is actually being used. And from the it's actually 111 followed by 0, and then out of the 32 bits 4 bits are taken, the remaining 28 bits are actually can take any value. That's technically what it means. These 4 bits are having the fixed values of 111 followed by 0, and the rest of the 28 bits can actually vary, but not all of them can be used for multicasting. You can assign it to the end users. There are certain IP address series which are actually reserved for some specific purpose. From 224.000.1 to 224.002 cannot be used, and another series from 224.0.1.0 to 239.255 to 255. This is actually can be used by for the multicasting purpose. And within that series as well, some of the IP addresses are, particularly these IP addresses are actually reserved for a specific purpose. So, if you use the IP address 224.0.1, this is actually it actually used to mean that you want to communicate only to the all those users within this particular subnet. And the second 224.0.2 will also mean that you actually transmitting, this is to be the communication should go to the all the users which are within the subnet, but yet interested in the receiving the multicast content. And there are a couple of other IP address series also which are reserved for some other purpose, particularly for the routing application, they are actually reserved. So, that is a way of doing the optimization.